What's up, guys?
How's it going?
Better find some paper.
You had all those babies in my room.
I like the doc mask with the mustache there.
Sweet. Well, I gotta go at like 6:45, so
Okay, so we should get started.
we should probably get started.
Okay. I thought I'd go to Italy while we're at it, so.
We're not gonna go to Italy.
Oh, there we are. Yeah.
Snorkeling in Italy.
All right. Is it laggy for you guys too, or is it just my computer that's really laggy?
It's laggy.
Yours is too. I want to see it put the dog mask on your dog.
That's what I'm trying to do. That's what I'm trying to do.
You hide your face.
Oh, there it is.
It doesn't work.
It worked for a second.
Yeah. He's not cooperating.
We gotta have the sound effects.
Yeah.
There we go.
All right. So, did you guys think the lesson was all right, or did you guys have questions?
Yeah, it was alright.
Okay. I like that it's kind of all the same, but with slightly different symbols and stuff. So it's not too bad. It's kind of a review, I think.
Yeah. That's when I was kind of confused at first, and then I realized, wait, this is like the exact same thing as we did last week. We're just
with the T.
taking differences and doing it with those instead of the actual values.
Yeah.
Right.
So now I just gotta remember how we did it last week.
Yeah, last week it was really lame because I didn't even know how to use the Excel thing. Like I didn't know about it, so I was super confused. I didn't know how they were coming up with these answers, but
Yeah, it was kind of confusing.
luckily I figured it out. Okay, do you guys want to start the quiz?
Sure.
Sure.
Okay.
All right. True. Number 3. Suppose we have a set of paired data and let D equal x after minus x before. The null hypothesis is that the difference is 0. I don't know how to read that necessarily. The mean difference is 0. The alternative hypothesis is that it is not 0, and the population standard deviation is not known. Jordan collects a sample size of n equals 9 and computes d bar to be 2.2, and the standard deviation of the differences is 3.3. What is the value of the test statistic? Alright, so
this one, it looks like we actually have to do it by hand.
yeah.
Let me get
Now the test statistic, that's the t-value, right? Is that correct?
I think so.
Yeah, I think I'm pretty sure you're right. It is. So for this one, I think we need to do the equation, is it t equals d bar minus 0 over the SD thing divided by the square root of n?
Yes, I think so. I believe that's correct. Let's see.
But what is, I'm thrown off by, it says suppose we have a set of paired data and let d equal x after minus x before. Where do we get,
Yeah, which we don't really need because they've already given us d bar and standard deviation.
so that's just extra information we don't even worry about.
So, at least in this case.
Okay. Cool.
So, hey, how do we find, because so that's the t times,
So,
or is that not right? Let's see, you said it was,
I'm thinking that it's t equals d bar minus 0 in brackets, and then underneath that divided by sd divided by the square root of n. I don't know if.
oh yeah, test statistic, okay, yeah. So that would be 2.2 divided by 3.3 and the square, or divided by the square root of n.
Which is 3.
Yes. We take 2.2.
Okay.
2.2 divided by 3.3 divided by 3. So 0.222. I just got 0.2222222.
I got 2.
2.2 divided by 3.3 divided by 3.
Hold on. I need to get a calculator here.
So it's 2.2 divided by 3.3 divided by the square root of 9, right?
Yeah, and I think wait, let me.
No, it's 3.3 divided by the square root of 9 and then 2.2 divided by that number. Because the
Yes.
order of operations would change it.
Okay. 3.3 divided by 3 then.
Yeah, I got 2.
2 even.
Yes.
Sweet. I hate it when they don't tell us what to round to.
I would just assume 3.
Okay.
Because,
Okay, I got it then.
Then it's going to do 2.000.
And then you divide 2.2 divided by the number that you got. Okay, so yeah, I got that then. I got
yeah.
2.
Sweet.
Okay. So 2.0.
I always forget about changing the order of operations.
Yeah, it can be tricky. I forgot that too today. Okay.
All right, the probability of being greater than 2.0 is 0.0403. Use the alternate hypothesis to determine the p-value for the test.
Huh. Okay.
Wait, oh, the probability of being greater than that is that?
Yes.
Yeah.
So would we take that number and multiply it by 2, and that's our value, our p-value?
I don't know. I really don't know how to go about this one.
Because a p-value is the probability that basically it's the probability that the null hypothesis is wrong, right?
Yes.
So if they're saying that the probability is of being greater than 2.0 is that, now our alternative hypothesis is that it's not 0, which means we need to include less than as well. And so really we can just multiply that, because I remember him saying before that if it's a one-tailed p-value, then you would take your normal number that SPSS gives you and divide it by 2. So I'm guessing here, since this is one-tailed and we want it to be two-tailed, we would multiply by 2, and that would give us the p-value.
All right. That sounds good.
That's
I
my
really,
guess.
Ken?
Yeah, I really don't know. So
I'm assuming that's the case since he's giving us that number.
which one? The 0.0403?
Yeah, the first sentence at all.
Uh-huh.
And then it says use H, the alternative hypothesis, to determine what the p-value is. And so since that's not equal to 0, it probably means we just multiply that by 2.
So I get 0.081.
Yep. That's what I got.
Okay.
Cool.
5 says, use the data file chapter 12 data A to answer questions 5 through 10. Make a column of differences in SPSS using null hypothesis of UD equals 0 and alternative hypothesis that it does not equal 0 and level of significance alpha 0.1. So what is D bar? Round to 3 decimal places. Okay, so there's a data A, chapter 12 data A thing we have to open up apparently. Is that just?
Oh. And by the way, the same Excel spreadsheet we used last time has a paired sample t-test.
Right. It's just a different sheet,
You're right.
right?
Yeah.
Okay.
Just to make sure you know that it's there.
It actually took me a bit to find it today, so.
All right. So let's go see if we can find that data. Has anybody found out where it's at?
No, not yet.
I remember seeing
That's
it
what
on
I'm
the...
looking for right now.
I'm thinking what you have to do is go to the today's reading, and then I think there's a little link thing where you can get a hold of like all of those
Today's reading.
things.
What are we looking for again? Data A. You know what? I'm just gonna do this. I go to main. Oh, data files. There we go. Chapter 12, data A. Sweet, found it. Copy link address.
Are you gonna send it to us?
Oh, sure, why not?
Yay.
There you go.
Yes.
Oh wait, where did it go? I saw it poke up, but then it went away.
Okay, I'm gonna send it again. Oops. There's all the data. Ah, dang it. Copy address. There we go. Is it there?
Sweet, got it.
Sweet. Where's my Excel? There it is. Sweet. Okay. Use a null hypothesis of 0, the alternative hypothesis there. The level of significance is that's 0.90. Okay. So, gotcha. Okay, did you guys get it up?
No, not quite. It's taking a while. Okay, so null hypothesis is 0. Then type of test, what was it? Not equal to or something?
Yeah, not equal to.
And we're doing confidence level of 0.95?
0.9 because the alpha is 0.10.
Oh, okay. So 0.90. Okay. And then we need to figure out the difference too, huh? Okay.
So we're finding d bar, which is the mean of the differences.
Do you usually do variable 1 minus variable 2 or the other way around? Or does it even matter?
It would just change the sign. I'm assuming he wants us, it doesn't say here, but I'm assuming we just put it in the same way it is in the other Excel sheet. Because I have group 1 and group 2. So I'm just going to assume it goes the same way.
Pick it up. Go off the carpet.
What did we need to find? D bar?
D bar, yeah.
D bar, yeah.
That's just the mean, right? Of the differences?
Yep.
I got negative 31.025.
I got 31.025.
Okay. Yeah. So it's probably yours because it probably can't be negative. Or maybe
Yeah.
it can, I don't know.
The mean could be negative.
All I did, the difference of what we did was you probably did variable 1 minus 2. I did it the other way around.
2 minus 1.
So, I mean, I don't know. We could just go with positive.
Let's see. Yeah, I just threw it into the paired sample t-test thing. And that's the way it did it. Yeah, it did. Yeah, it does variable 1 minus variable 2.
Okay. So yours did it for you? Like, I had to do, like, the cell. I had to make it do that. Like, but when you plugged it in, it just computed the difference?
Yeah. Is this the one you're looking at?
Let's see. Hold on. Paired sample t-test for means. Yeah, that's the same thing.
Yeah, the differences were already set up. Oh, when I cleared it out, I just selected these ones and then said clear data. I wonder if you accidentally selected the difference ones as well.
Yeah, I probably did.
That might have done it. Anyway, so yeah, they do A minus B, which is variable 1 minus variable 2.
Okay. Yeah, that's fine.
So
Okay.
31.025.
0.025. So then, what is the standard deviation? Is it 34 or 341.157?
Yeah, that's what I have. I think that's it.
341.57. Maybe, or
I think so. Let me double check.
it would be to the third decimal place, all right? 0.57 or 570.
It's 341.157.
157.
341.157. Okay.
What is the test statistic?
Is that just asking for T?
Yes.
Yeah, that's what T would be. Yeah.
Yeah, I think so.
Hold on. Mine says, yours might be positive. Mine says negative 0.407.
Yeah, mine's positive, but that same number.
Okay. And then the p-value, I got 0.689.
That's what I got too.
Cool.
What is the correct decision based on this evidence?
Fail to reject. Right?
Fail to reject, yeah.
Okay.
And the next one says, suppose your alternative hypothesis is greater than instead of not equal to. What is the correct decision based on this evidence? I said fail to reject the null because you just take the p-value and divide by 2, and it's still more than the alpha.
Okay.
I think.
So I went into Excel and I just switched type of test to greater than, and the p-value is still 0.656, so it's still fail, right?
Yeah.
Yeah.
When I change mine to greater than, it goes to half that.
Oh, does it really? Are you in Excel or SPSS?
I'm in Excel. Here, let me show you. So right now it's set to not equal to. If I change it to greater than, the p-value is half what it was.
Huh. That's weird. Why did...
Yeah, I don't know why yours would do that.
Yeah, I don't know what I did.
Either way, it's still above 0.1, so it doesn't really matter.
Okay.
But, yeah, I think it should be half. Because that's that whole two-tailed thing.
Okay. So I wonder if somehow, like, I changed it. Oh, you know what? Now I'm getting 0.344 because I switched it to how you did it, the variable 1 minus variable 2. So apparently that does make a difference depending on...
maybe the algorithm or one of the formulas he has in there doesn't work on negative values or something.
Yeah. Okay, well that makes sense now. Alright, let's see. So yeah, still failed to reject. Okay. And then 11, it says, use the data file chapter 12D data B to answer questions 11 through 18. Make a column of differences in SPSS. This data comes from that. The A null hypothesis is UD equals 0. What is greater, N or DF? Okay, so is this the same thing we opened up, that chapter 12 data B, or did we do something else?
We did data A. I just sent you a link to data B.
Oh, okay. Let me get that.
Alright, let's see. Copy. Content. Special.
Real connection, first of all, as a point of entry, is super important, which is part of the reason I think Julia was a great housewife. She has history.
So we just plug in the same info?
For whatever reason, first season, there was some that really, like Jim and Ramona had a connection.
Which is greater, N or D? Wait, is that even a question? Isn't it always going to be N?
Maybe. I don't know.
Because DF is N minus 1.
Oh, yeah.
That's funny.
Okay, so in it is. We didn't.
We spent like 3 minutes on that problem.
Yeah. I don't know. Which is it?
Let's check it out. Okay.
All right, your alternative hypothesis. And your UD. Okay, so, and use a level of significance of 0.01 what is the p-value?
Okay, so now we have to change it to 0.99, right?
Yes, I believe.
And not equal 0?
Oh yeah, I need to change that from greater than to not.
Not equal to, yeah, not equal.
See, I got 0.001.
What are we looking for again? The what?
The p-value.
P-value.
0.001, yep.
Yep.
All right, so 13 is, what decision do you make? Reject it, right?
Yeah.
X less than.
Yeah, I reject the null. All right, number 14 says you decide to try another alternative hypothesis. This time you say that it's greater than 0, and you keep the same level of significance. Did the p-value increase or decrease? It should have decreased. Let's check. Yep, it decreased.
All right, so then what do you decide? What decision do you make then? Do you reject it, or do you fail to reject the null hypothesis?
Oops.
Let's see.
Sorry, I'm eating while we're doing this.
What are you eating?
What is it?
Grilled chicken over steamed kale.
Grilled chicken over steamed kale broccoli stir fry.
Wow, look at you, Mr. Healthy.
That's my wife.
Yeah, go for her.
I know. It's pretty good too.
I think I'm gonna have a bowl of ice cream tonight. That's what I'm gonna have for dinner.
All right.
Aren't you training for a marathon or something?
Yeah, Saturday.
Oh, no way.
Yeah,
This
dude. Whatever I want, man. That's this week is like whatever you want.
Awesome. So
It's really not that. It's really not like that, but.
Oh, really? What how long do you have to run for?
13 miles.
Dang.
Yeah.
That's
a couple miles.
impressive.
No big deal.
No big deal.
I did 7 last night, all downhill, and it was pretty fun. So.
Sweet.
It's cool. It'll be fun.
I'm gonna do a half marathon sometime.
I want to do a full one next. So.
Yeah.
There's one up in Cottonwood Canyon that my buddy wants me to do, so in Utah. So I might try to do that with him.
That'd be cool.
But,
So how long have you had to train for this?
I've been running since April, like a lot. I put in about 80 miles in April, and I put in about 65 miles in May. So altogether, it'll be about 150 miles probably before the race. So it's good.
Wow. Just to let you guys know, if you guys are looking at your effects, at the bottom there's a slot machine button, and it'll randomize your costume.
Yeah.
I didn't know that. So I just pushed it, and here I am.
Oh, I got nothing, dude. It just.
There we go.
Oh, there we go.
Oh,
The clowns.
Wow.
Hey, stop clowning around.
Yeah.
You dog.
All right, 15. Are we rejecting this, or are we gonna fail to reject the null hypothesis?
Let's reject it.
Just straight out reject it.
Yeah. Since we rejected before, the p-value decreased. We should probably reject it.
Since this
Wait, which one are we on right now?
15.
What was
I gotta go get my charger. Hold on, guys.
14 was decrease.
Decrease.
Because it's instead of being not equal to, it's a one-sided, so we halved it.
Oh, okay. And then 15 was reject the null?
Yep.
Okay, as we have seen, the p-value depends on the alternative.
16 confuses me.
Okay, setting aside the data in this problem, do you think a general rule can be made which alternative hypothesis will give the smallest p-value? Well, all we have to do is try it out on Excel, and it'll say. Like,
yeah, but it's saying set this data aside. So you
yeah.
have the data to try it out on.
But I'm saying like,
Oh.
if you still have your Excel open, you can just play with the numbers you already have in there.
All right, sorry guys.
Gotcha.
So, okay, so greater than, I have a number at 0006. Less than
Much bigger.
0.999. Yeah, so less than is way bigger, and then not equal to is 0.001. So it looks like greater than was the least, less than was second, and then not. No. Less than was the most, and then not equal to with these numbers was in the middle.
But wouldn't it depend on the problem? Because if the p-value is large for the not equal to and the greater than, I guess, then it would be really small for the less than.
Right.
Right?
Yeah.
So I'm kind of thinking it's the last one that says depends on the problem, because it depends on what the actual p-value is.
Yep, that makes sense. Yeah.
So it's not enough information, depends on the problem.
I think so.
All right.
Then determine
17. No, go ahead.
determine the 95% confidence interval for the mean difference between two groups. What is the lower bound?
All right. So
What is the lower bound? Like what are we supposed to put in there? Like,
so I think we're using the same data, I'm assuming. And we want to go in and set it to 0.95. And we're saying that it's, what is it, not equal to? Yeah, not equal to 0. And then that's the confidence interval. So that's the 5.303 to 18.607.
okay. And the lower one is 5.303, right?
Yeah, I think so. If I did that right.
Yeah. And then the upper bound, we just put in that other one, 18.607.
I believe so.
Yeah, I'm assuming we use that same information. Yeah.
That makes the most sense.
Cool.
So 18 is 18.607.
Yep.
What was 17?
It was like 5.303.
Sweet.
Okay. So we're good to go?
I think so. Should we do it?
Yes.
100%.
Yeah.
100.
Good job, team.
Nice.
We have a lot of hundreds in a row now.
I know. Hey, I wonder if we have a record. All right. Well, I better get headed.
All right.
All right, man. See ya.
See you guys.
All right, bye.
See ya.
See ya.